binary tree, we have what we call a node, and a node is something that has a value, and then acco- uh, according to this value, it will have a pointer on the left and a pointer on the right. Okay, so it will have three properties essentially. Then binary trees are also sorted. So I'll add it here. So values in binary tree are placed in order basically. So if the new value is greater than the value at the root, then we go towards the right, else we go to the left side. Okay, what does that mean? So we have 20 here. Now the next value we're going to add is could be 13. So 13, since it is less than 20, so it is going to get added to the left of the 20. And since we would be implementing this in code, we will have actual pointers to these left and right values. So we'll store the indices in the array. Then let's say if I have 30, since 30 is greater than 20, so it goes on the right of 20. And any given node will have two children. So these are called the child nodes or the sub nodes, or whatever you want to call it. And then any node that does not have any further children is called a leaf node. Okay, so this would be, so leaf nodes are nodes that don't have any children like this. And then root node is the one that we're looking at. This is 20. Okay, next time I'm going to add maybe 17 now. So what will have to 17? 17 will start from the root 20. We'll check is 17 less than 20? Yes. So we go to the left side. Now 17 is greater than 13. So we'll attach 17 on the right of 13 and we'll see. So left and then right. Similarly, if I have 25 here now, so 25 is greater than 20 and less than 30. So it goes on the left of 30. Then maybe I'll have 12. So 12 is less than 20. It's also less than 13. So it goes on the left of 13. And then maybe any value, maybe 38, which is greater than 20, greater than 30. So it goes on the right of 30. This is the essential idea. Now, the main thing we have to do in a binary tree is basically you have to remember and we have to track where we started from and what is on the left node, what is on the right node, and then the child nodes that they're referring to. Okay, so we'll look at the code now. This is the basic implementation of it. The next part we'll be looking at is how we'll be outputting the tree values and how we'll be adding values into the tree. And then also we'll look at how we output the values in a certain order. Okay, so there are three types of methods we can use to output the nodes in the tree. Okay, let's start. So first of all, we'll do it using the object-oriented programming method. Okay, this is also a past paper question, so I'm using that as a basic structure. So first of all, we'll have a class node. In class node, we'll have a left pointer, a data value, and a right pointer, and they're all integer values, right? So if I have the node 20, so initially node 20, the left pointer would be -1 and right would be -1. And -1 refers to the fact that it does not have, it's a null pointer. So -1 again means null pointer, just like we had in the linked list. Okay, so then we have some getter methods. We have get left, we have get right, we have get data. So these are the getter methods. Simple enough. They are just going to return the value, getter methods. And then we also have the setter methods. So they are going to allow us to set the values of these attributes. So we can set the value of the left, and we can set the value of right, and we can set the value of data. Okay, this is the basic structure. Okay, so pretty much straightforward. Then we are creating another class. This is just a basic implementation. It could be asked in different ways in the paper. It's not necessary they'll do it the same way. Now, in the tree class, we are supposed to create a tree which will store nodes. Okay, so the array will be there to store node objects. Okay, and what is a node object? A node object has three properties: a left, a data, and a right. Okay, then it will have a head pointer. So head pointer will refer to the start of the linked list. Start of the tree. Okay, so like in this case, it's starting from 20. So it will be pointing to 20, and then from here we'll go to left or to right. So, and then the number of nodes, this will be the total number of nodes that we have inserted overall into our tree. So initially we are setting the data to -1 because right now the tree would be empty, let's say. So I'll open another tab. So initially it's all empty, right? There are no values there, so everything is set to -1. Okay, now we're going to learn how do we insert a value into the tree. Okay, so again, we need to remember that this tree array, this is the array that is going to store node objects. So I'll probably make it here. So we'll have a tree array, which will have some values at different indices. So the first value of a node would be like this. So this would be node 1 and -1, -1, and -1. There would be another node, again -1, -1, -1. Another node, -1, -1, -1. So if you try to access the whole value of node, this will return you a gibberish address, right? We cannot access the whole object. So what we'll have to do is we'll have to use different functions. We'll have to use tree index 0 dot get left like this. Then we'll have to do the same thing to get right, and then we'll have to do the same thing to get data. Let's say I am adding just one value right now, which is going to be 20. So 20 will be the new root value. So what I'll do is that at this point, I'll just go and I'll say tree index 0 dot set data, and this would become some value, and set data is supposed to get some data value, and this data value is supposed to be an integer value. So let's say I pass in 20 like this. So this would now be, this is now how the tree would look like. But the left and the right pointers are still null. And so this is how the tree array would work. Okay, moving on. So now what are we going to do in insert node? We're going to give it a new node. And then first we're checking if the nodes are equal to 0. If the nodes are equal to 0, that means that we are adding a root node basically, right? Whatever node we add, it will become the root node or the first node, which is going to be 20. So what we're doing here is we're saying that whatever the index, whatever the name of the array is, in our case it's tree, at the 0th index, we're going to put the new node, right? Because it will be the first node in the tree, so it will automatically go on to the 0 node. And then head pointer is also supposed to point to 0, and then number of nodes +1. Okay, so what has happened? So if this is the tree array that we have, so this is the tree array maybe, and we just place the first node, and I'll write the value with 20, and then we set that the head pointer is now going to point to 0 as well. So this is now going to be the head pointer like this. I'll just point it here. So this is what it's doing. All right, then we are saying number of nodes plus equal to 1. So this is basically like the previous pointer as we do in linguist. This is going to point to how many nodes have already been stored. So number of nodes will automatically go on to the next index. Imagine it as the next place where we'll be storing the node value. Let's give them a different color. Okay, here we go. All right. So this was the first part when there is when there's no node in the binary tree. Okay, if there is already some node or multiple nodes in the binary tree, now what we're going to do is we're going to get the value of the head pointer, and we're going to start from that. So we know the value of head pointer right now is stored at index 0. So it will be
If
storing
we
20.
only added a head pointer, then why is the number nodes pointing to 2?
Where?
In line 53, as in we only added 1 to it, so it'll have 1. But in the diagram, we pointed it to 2. So what exactly is number nodes?
We pointed it to, oh, okay, my bad. So this should be 0, 1, and 2 like this. Okay, and this is just when taking account how many nodes we have. So we've added one node, so the next this would be the basically the pointer to the next available space in the array. So if I have to add another node, let's say node 13, so number of nodes will exceed and go one step ahead to node 2, to index 2. Then we add another node and it keeps on moving. And this keeps on moving until it reaches the size of the array, which could be 50, 60, 100, and we'll say that the tree does not have any more space. Okay.
So if the number nodes pointed to 5, then would we add a node there or not?
Yes, we'll be adding a node there.
Okay.
Okay. So we start from the head pointer. We set the previous to -1. You'll see what -1 does, and then we have the direction. Okay, just like I discussed before, that whenever we have to move in the binary tree, we decide if the new value that we have to add, if it is greater than the root, then we go to the right side or we go to the left side. So every time we have to decide the direction on each part of the tree. Okay, so while the node access, again, node access is starting from the head. This is the current node. Basically, it's not equal to -1. Then we're going to keep track of the parent node. We'll see the current node is now the previous node. Meaning, so when I start from 20 and I go to 13, so 13 is now the current node and 20 becomes the previous node. That is what we're doing. Okay, so we have to add a new node. This is the new node here. So we'll get the data value of the new node. Let's say
What's node access?
it's just the current node. We set it to the start.
The pointer of the first
Yes,
node?
it's the pointer of the array, basically. So it will start from 0. Okay, so here we check if the data value of the new node is less than the data at the current node. If that is the case, then we have to decide where do we have to go.
Why is previous -1?
It's just initialized here for any value. It will eventually get overwritten. It's just to make sure that there would be a previous value because we're starting from the root, right? If there is no root, so the value would remain -1, or if you can just set it to 0 or something. It's fine.
And node access not equals to -1 is making sure that it's not a null node?
Yes, we're making sure of that, yes. Okay, so we are at the value of node access now. Node access is set to the start of the starting in pointer. Okay, so we're checking the new data that we're going to add. Let's say the new value we're going to add is going to be 13. So we are checking the value at the first index, the first node. Is it less or is it greater? So since 13 is less than 20, we're supposed to go on the left, right? So in array, it won't have any directions because arrays, we're using one-dimensional array. So I'm using both of the forms so you guys can understand. So this will be added into the array, and then I'll add the 13 into the tree, and then it goes on to the left side, right? Now, how does it happen? So we first are checking if the current data of the new node is less than the value at the current index of our tree, its data value. So if it is less, then it means that we're going to go to the left side. Okay, and before that, we're going to check if there is actually a value on the left side or not. If the left is null, so let's say I'm at 13 right now. So 13's left is null. That means there is no node on 13. So this is where we're going to attach the new value in. Maybe we have 5 here. So 5 is less than 20, then 5 is less than 13. So we'll attach 5 here on the left. So this will make sure that if we have -1, it means that there's no node on the left side. We'll remember the direction and we'll break it here because we found the right insertion point. Okay, if that is not the case, if the left value is not -1, if there is some node here, so what we'll do is we'll eventually go to the left of the node. So let's say we started from 20. Since 20 has a left node, so we go to the left value of it, which is going to be 13. How do we access it? we are going to, again, you go to the current index of the tree array, and then we're going to get the left value. So what will get left to? Get left is a getter method, which will simply return you the value of the left pointer, which is going to be an integer value, which will point to where the left value is stored in your array. So this is what's happening so far. Again, what we're doing, we're checking if the current value less than the current is less than the root value. That is true. We're checking if there is actually a left value. If there is a value on the left to the root node, if there is none, so we store the direction and we break it. If that is not the case, if there is another node on the left side, we are simply going to get the pointer to that node so we can access it. Otherwise, if that is not the case, so we check if the current data is greater than the data on the current value. So example being, let's say I'm adding 90 now, so 90 is greater than 20. So we'll do the same process now. Since 90 is greater than 20, it will go on to the right side. So we are checking this. Okay, so then we're doing the same thing for the right side. So we're checking if the new node that we're going to add, if the data value fit is greater than the current node that we're looking at. If that is the case, then we check if there's a right node that is already existing. Again, so let's say we have 90 here and the new value I've had to add is 100. Since there is no value to the right of 90, that means 100 would get inserted to the right of 90. Otherwise, we will continue and keep on searching until we find the right insertion point. So
But
like
aren't we looking with reference to the head pointer? So in head pointer there's 20 and in the right of it there's 90. So isn't that like full?
in this case,
Yeah.
how is it full? No, so I'm assuming we're
Because
adding, I'm assuming we're adding 100 here. So if you're adding 100 here, then we'll go to the right of 90. Yeah?
will we not first look at the head pointer as in 20?
Yes.
Because that's
And
what's in node access. And since
yes,
to the right of that there's 90, isn't that full?
yes, that is true.
Okay.
So since there's already a value here and it's not equal to -1, so we're going to just simply go to the right side. So we go to the right side and we find that there's a 90 here, and then we repeat the same thing. So let's say if I'm inserting 100 here, so I'll check again, is there any value to the right of 100? And since that would not be the case, sorry, is there any right is value to the right pointer of current node, which is 90? Since that is going to be -1 because there is no value to the right of 90, so we're going to break it here. And then
I'm
we're going
not
to,
understanding how we're going to the next node. Like, aren't we looking at the head pointer be as in this case it's 20? So how are we comparing it with 90?
okay, so this is where the comparison happening. So 90, like new node की जो value that is 90, right? Yeah, new node बल्कि हमने क्या कहा है? New node is 100. So let's write it down.
And node access in this case is 20, right?
Yes, new node is 90, and node access, no, node access is not going to be 20. Node access हमने start किया था head pointer से. So head pointer stores 0 right now. It's not storing 20. So ये मैं values यहाँ पर लिख देता हूँ. We have node
So
access.
the first index is 0 and that's 20 in our, like the value for it is 20.
ठीक है यार. So new node है और यहाँ पे node access है, and then let's
So we're comparing it with 20. तो मुझे 90 की नहीं समझ आ रही. Where is that coming from?
90 is the parameter that we're sending in new node में यहाँ पे.
Aren't we sending in 100?
एक सेकेंड. ओके 100 है, ठीक है. सो अभी हमारे पास न्यू नोड की वैल्यू 100 आई है, राइट? ठीक है, लेट्स स्टार्ट फ्रॉम हियर. सो हमने नोड एक्सेस को भी 0 पे सेट किया. वी चेक द वैल्यू at of the new node which is equal to 100, is 100 less than the value at the 0th index, which is not the case. 0 पे आपके पास 20 है. 100 is greater than that. So what we're going to do is we're going to say get the right node of this index 0. ठीक है. अब हम जब इसके राइट नोड पे आएंगे, सो यहाँ पे 20 के राइट पे भी इनिशियली आपके पास कुछ भी नहीं स्टोर होगा, बिकॉज देयर इज नो अदर वैल्यू. तो अभी -1 पड़ा हुआ है. इसको भी ना हम दोबारा से कर लेते हैं. Let's bring it in this format, 20 and 13. So 20, 13, and then we have 90 here. Let's add, okay, we were adding 100 here. Okay, so now when we're going to add 100 here, we'll check कि आपके पास जो करंट नोड एक्सेस है, नोड एक्सेस में you had 0. So 0 के जब हम राइट पॉइंटर लेंगे तो यहाँ पे essentially आपके पास जो नोड की वैल्यूज है वो इस तरह से they are -1, -1 like this. And similarly जो 13 है, 13 बल्कि यहाँ पे आपका जो लेफ्ट वैल्यू है that would be 1. It would be like this. And 13 के लेफ्ट पे it will have -1, -1 like this. ठीक है. Okay, so when we're going to add 100 here, it's the value is going to be greater than the root value, which is 20. So we're going to say कि node access यानी कि जो भी index 0 के जो get right की value वो आप get करो. अब जो आप node के right की value get करोगे वो -1 पे set हुई है. Since it's set to -1, the action is going to set to right and it will break. And then we're going to at this index we're going to get the right value, which is again going to be -1 for now. जब ये आप यहाँ पे -1 करोगे तो this loop will eventually end. And once this loop ends, यहाँ तक समझ आ गया?
Yeah.
Okay, so should we move on? It would make
I
more
just
sense
need
then.
to ask, after the break, do we go to line 75 then?
Yes, because break will just okay, no, sorry. Break will end the while loop. Yes, so we will not do that. We'll get directly
And
go to
what
line 7.
is, if we did go to line 75, what would that do?
If it did go to 75, so it will just get you the next value. So let's say आपने यहाँ से start किया, so you are looking to add maybe 5 here in the tree. So 5 is less than the value at the root, which is 20. So what we're going to do is we're going to say that get the value on the left of the root node or the current node. So we'll go and we'll get the value on the left, which is 1, right? So क्योंकि हमारे पास 13 भी stored है यहाँ पे, so we have 20 and 13. So 20 के left पे हम यहाँ पे 1 stored है. So now the value of node access becomes 1. And then node access की value 1 होगी, so previous becomes 1. And then node access की यहाँ value 1 थी, so यहाँ पे हर सबकी जगह 1 आ जाएगा. Then we go to node index 1 and यहाँ पे we'll find 13. And then let's say if you are inserting 5 here, so the same logic applies. Since अब अच्छा अब आपने इंडेक्स 1 के लेफ्ट को हम दोबारा से एक्सेस करना है, सो इंडेक्स 1 के लेफ्ट पे -1 पड़ा हुआ है, 13 के लेफ्ट पे -1 है, सो वी गोइंग टू रिमेंबर दिस एंड वी गोइंग टू ब्रेक द लूप. सो ये वाली जो लाइन है ना, दिस एसेंशियली मींस कि ओके दिस इज नॉट द राइट इंसर्शन पॉइंट, सो गो टू द नेक्स्ट लेफ्ट और गो टू द नेक्स्ट राइट, एंड वी कीप ऑन डूइंग दिस अंटिल वी फाइंड द राइट पॉइंट टू वेयर विल स्टोर द वैल्यू. Make sense?
Just 1 second, I'm just looking at it.
Okay. You can open the code as well in front of you. आपको collab file में भी है.
Yeah, I have it open.
Okay. Where do you have it open as well?
So if the node that we're trying to insert into, if it's -1, then we break the loop because we can store it in that node. And if it's not -1, then we need to find a new node access, as in
we need to find new node access. Yes, so again, ये वाली logic. So if you're going to add 100 now, let's say you're going to add 5 now. So आपने यहाँ पे start किया. So you start node access from 0 and you read, is there a value on the left? This is what we're doing here. So let's say if you want to add this value in a tree, you have 20, 13, and 5. So we have added 20 and we have added 13. Now we're going to add the value 5 into our tree. So we'll start from the root node. We check is the value that we're going to add, which is, let's say 5, is this value less than the value at the root node? So at the root node, we have 20. So since it is less than 5 is less than 20, so then we're going to check, get the left value of this root node and see if there is space on the left of it, or basically if it's null. So we do that, and we know that on the left of 20, we have 1, which is pointing to this row. That means it's not equal to -1. So this condition would not work. And what we're doing here is that we are saying that get the left pointer of the current node and make this the new node access. Basically go to the next node, just like we do in the linked list.
And then
So
a loop
yes.
will continue and we'll check the left and or right of the next node that we're looking at.
Yes, exactly. So now we'll go to the left of the node at 0th index. So at 0th index, the left was 1, the left pointer. So now the new node or the node axis is going to point to this node, which will be 13. Okay. And then this while loop will repeat. Since node axis is not equal to -1, we repeat the same process. We get the value. So currently the value would be 13. And then we get the left value of 13. So if we get the left value of 13, by default, it will be set to -1, left and right both. Since they're both set to -1, or the left is set to -1, we'll remember the direction that we have to go left, and then we'll break. And because of this break, the whole while loop will end. And then what will happen is the new node, which is essentially 5 in our case. So if I just write it in -1, 5, -1, basically node will just have the data value. We're assuming that the left and right pointer will be set to -1. Okay, so in the constructor we're just passing in the data, but -1 and -1 are set to both left and right. So what we're going to do here now is we're saying what the value with node 5 that is going to get stored at this index, which is number of nodes, which is the number of nodes that we currently have inside the tree array. Okay, so the number of nodes we have right now are equal to 2. So number of nodes would be pointing to 2 here. And then what we're going to do is we're just going to go ahead and we're going to store 5 in here. So we are going to store node -1, 5, -1. But as of now, we have not changed any pointers, right? So we have added 5 to the left side, but this link from 13 to 5 has not been established yet. So in the final step, that's what we're going to do. And remember, we had written the direction here where we went. So we were going to the left side. So then we check here if the direction was equal to left. So what we're going to do is we're going to get the previous node, which was the previous index, which in our case would be 1, right? Because this is where we were at right now and previously, and this is the new node that we added. So this would be 1. And we're saying go to the index 1 and set the left pointer to the number of nodes, which is basically again the free node pointer. This is where the new node has been stored. Okay, and what was the value of the new node, which was, it was 2. So this is what's going to happen. We are going to go and set the left of the node at index 1 to value 2. So we go to index 1, we set its left to index 2 like this. Now our link, our array and our tree are looking exactly the same. So this is our head pointer. Let's start. We read 20. Okay, then it says on the left, go to index 1. So we go to index 1. Then we have 13, and it says on the left, go to index 2, and we go to 5, and then there is nothing to look forward to. So it is looking like a skewed tree on the left side. So this is what's happening essentially. And then at the end, we're going to increment the number of nodes by 1, which is again pointing to the next available space. We're going to add the new node. So this is how the insert function is working. So this is how the insert function is working basically. All right.
Can you explain what previous is, as in where is it coming from?
Okay, so the previous is just a value that is storing that starts from -1. And then what we do is whatever the current value is, we just store it in previous as a copy. Okay, so initially node access was set to 0, right? Because we're starting from the head pointer. Head pointer is set to 0 here. So node access becomes 1. So previous also becomes 1. Previous also becomes 1 like this. Then all of this process happens, and eventually you are going to get a value in previous. Let's say it was 1, okay? Or maybe you change the value of node access. This time you went to index 0 and you went to the left side. So now node access becomes index 1, or it becomes index 2. So next time this loop runs, node access had 2 in it. So previous would also be 2 now. So it is just remembering what was the previous node you came from. And then when the while loop ends, that is how we're able to access the value of the previous node. That's it.
Can you explain the code in line 81?
Okay, in line 81, we are saying whatever so when we are adding the node into our tree, so let's say I'm going to add 18 here now. So 18 goes on the, okay, let's add maybe 30. So 30 goes on the right of 20, right? Now 20 basically, okay, so we have two nodes, so maybe let's add another one. Maybe let's add 50. Okay, so what is going to happen is that we started, the current node would be 20, and then 30 becomes the current node and 20 becomes the previous. So 30 would be the node access and 20 would be the previous, and then 50 would be the current, and then 30 would be the previous. So now when we have to add a value, we have to basically get the pointer from the previous node that we're going to link to. So whatever value we'll get, we would be pointing it to 50. So if the next value comes out to be, let's say, 45, so 45 has to,
So is number nodes the same as previous?
no,
I mean, no, sorry, node access.
node access is just in, so node access, yes, it's just a copy. The previous is just a copy of node access. It just helps us track from which node we were coming from, so that we can join the and update the pointers to it accordingly.
When will node access
So
equal -1?
When will we, sorry, what?
When will node access equal -1?
When will node access equal -1? Okay, so when we get the left pointer or the right pointer of this, so when this break does not work, which means that the value is not -1, so we'll try to access the value on the left side or the right side. So when we try to access a value, let's say we're at this node, maybe we are at node 5, and we try to access the value. So eventually it becomes -1. Okay, just a second. So node access get right is equal to -1. The break. Okay, so initially we have set the node access to, so there are two possibilities here. In one case, you start from the head pointer. So let's say you do not have any values at all. So in that case, node access would be -1. We're setting it to 0. We could set it to -1 as well. Okay, then that is the point where you can end the loop. Secondly, when we are getting the value here at this side, at this point, this is where you can end up getting a -1 as well. So maybe you have a node where there is a value on the left side. So maybe you have 30 here. 30 has a value on the right side, but 30 does not have a value on the left side, right? So when we'll get the left of 30, it will return you -1. So that is how node access can end up becoming -1, which will cause this loop to end.
Okay.
All right, so that's it. So just another dry run of this program. Let's say if I add another node here, so what's going to happen is, let's say I'm going to add 20, 13, and 5. So I'll refresh it. We have 20, we have 13, we have 5. Okay, now I'm going to add 35. Okay, so I've added 35 here. Now let's see how it will work. So when we add 35 here, I'll undo the code. Okay, when we add 35 here, we start from the root node and we store that in the previous, and we check if the new node value is less than the current value, of the root. So we're looking for 35. 35 is greater than 20. So since there is no value right now, so if I delete 35 and let's say, yes, so this is gone, but now I'm about to insert 35 into my tree. So there's no value to the right of 20. So since the get, this will trigger a -1, which will mean that will break here and we'll still remember the direction. So we'll go out of the loop. And then the new node that we have, which is 35, it will go on to the number of nodes pointer. So number of nodes will be pointing to index 3. Here we'll go and we'll store -1, 35, -1 like this. Now we have to update the pointers. So we check if the direction was equal to left or right. So since the direction was equal to right, we're going to the previous node. Okay, again, what was the previous node? So previous node was basically this 20, where we came from. And since there was nothing on the right of it, so this would be the previous node. So we go.
So if we're storing in the right of 20, then basically the node access is the previous node.
Yes, kind of, you can say so.
Okay.
Okay, so at the previous node, this would be wherever 20 is stored. So 20 is stored in index number 0. So we're saying that at index 0, go and set its right to the new index that you have placed the value in. And we place the new value in at index 3. So that's it. So we'll go to node 0 and node at index 0, and we'll set the right to the index pointed to by number of nodes, which was 3. And then we'll increment the number of nodes by 1. So let's make the tree now. We start from 20. Okay. So then if we'll, let's say we are adding 13. So it says go to the left and we are adding 13. Okay. So then after 13, we added 5 here. So then we go to the left of 13, which is at index 2. So we go to index 2, we get 5 here. And then so this is the left side, right? Now, if you go back again, and if you read the node 20 and you see the right, so it says at right, go to index 3. So at index 3, there is 35 here. So this is exactly how it would look like. 35 on the right and 13 and 5 on the left. This is how it works. This is your insert into a binary tree function. So if you guys get this, then output is pretty simple. What we have to do in outputs is we first have to check if the number of nodes is not equal to 0. If that is the case, that means there are no nodes in the binary tree. If that is the case, if that's not the case, then we're going to run a for loop for the number of nodes, which means the number of nodes available in the linked list, which would be, in the tree, which would be up till index 3. And then we are just going to print the left pointers and right pointers. How do we do that? We're getting the value of the current index from the tree array, and we're getting the left pointer of it using the get left. Then we're getting the data on the same index by using get data, and then we're getting the right by using the get right. And this keeps on happening again and again. And then lastly, if you want to test the code, we are going to create a tree like this, and then we're going to add some values. So these are values, and we're converting those values into nodes. And then we're inserting nodes into the tree using insert node function. And if I run this code, so this is how it would look like. So it will give you all the pointers to the left and to the right and the data like this. So this is how we add values into the binary tree. Okay, this was using the object-oriented method. Now we'll look at the one with 2D arrays. If you understand this method,
understand the insert the node wala code still.
which part?
Line 78.
Line 78. Okay, what about this?
Okay, well, I don't understand what's happening in it.
When you're not adding you're adding the node here basically. वो आपका इस पार्ट में यहाँ पे आपका नोड जो है उसके आप पॉइंटर्स को अपडेट कर रहे हो, ठीक है? दिस वे यू एक्चुअली पुटिंग इन द अरे एट दिस पॉइंट थ्रू आउट दिस व्हाइल लूप यू जस्ट फाइंडिंग द राइट स्पॉट फॉर पुटिंग द नोड. Once
So
you find
why
the
are we
right,
using number nodes as the index?
Where
78.
Okay, because the number of nodes is basically pointing to the next available space, like I said. So अब देखो number of nodes यहाँ पे fourth index पे point कर रहा होगा. So जो भी new node आएगा वो आपका fourth index पे store हो जाएगा. So let's say the node is going to be maybe 99, but 99 के अभी pointers जो हैं वो आपने -1 पे ही updated है, ठीक है? अब 99 किस वैल्यू से लेफ्ट या राइट पे आएगा वो हमने डिसाइड करना है, एंड दैट इज व्हाट्स गेटिंग डिसाइडेड हियर. सो इफ यू हैड प्रीवियसली डिसाइडेड कि 99 वाज going to the left subtree or to the right subtree, depending on that you will actually update the pointers here. So if it was going to the left तो आपने देखना है कि 99 से previous value कौन सी थी. Let's say if I add 99 here, so 99 से previous value थी 50. सो आपने क्या किया यहाँ पे, आपने 50 के राइट पे जाके आपने जो भी उसका न्यू नोट है यहाँ पे भी आपने उसको रखा है. सो यू स्टोर इट एट इंडेक्स 4. सो यूल से कि जो भी आपका करंट प्रीवियस था, maybe let's say it's going to the right of 35 which is at index 3. so you're saying कि index 3 के जो right है उसको आप सेट कर दो index 4 के right पे, like this. So now index 3 का जो right है, instead of -1 it will now be pointing to 4, and then this becomes this would officially link the node into your binary tree. That's the idea.
Okay, ठीक है.
All right. Okay, so this done. Now we have to learn it. How do we use it using 2D arrays? Also, deletion of node is not part of the syllabus, so we are not going to do that. Okay, now using 2D arrays. So what we have here is, first of all, we have a 2D array. Okay, so we'll literally convert this into a 2D array now, and the logic would remain the same, except there would be 3 columns now. So column 0, column 1, column 2. This would be the left pointer, this would be data, and then this would be the right pointer. And let's split these. Okay, here we go. Okay, so we have left data and right. All right, then we'll have some variables here. We have the root pointer, we have the free node, and we have the size. Okay, so again, this is the equivalent of node access, which is just pointing to the next available space. Size is going to be 7 for now. Just you can change it to whatever you want. So in this specific case, the 2D array will have 3 columns and it will have 20 rows. Okay, so I don't think we're using the size variable anywhere, so we can just ignore this for now. Okay, so we'll add the data. For this, we'll global all the values, and we're going to check if the free node is greater than 19. So we start with the add node. We global all the values. We check if it is greater than 19. Why 19? Because the size of the array is 20, and we're starting from 0. So if it becomes greater than 19,
What's
the tree
the
is full.
free node? What's free node?
Free node is going to be the number of nodes that we have, or basically the current free index that we're going to store the value in. So let's say if we have some random values here, -1, 20, and -1. So free node will be pointing here to node 1. This is where the new node will go in. It's literally the same as the previous pointer from the linked list. Let's kind of okay. All right. So then at every index, we're going to, for every new node, we're going to assign -1 to the left, -1 to the right, and data to the in column 1. So that's what we're doing. So what we're going to do is, free node is right now maybe, let's say, so we'll restart this and we'll start with some values already in the binary tree. So we have 20 and 13. So I'll update here. So we have 20 and then we'll have 13, which means the left of 20 will be pointing to index 1, and then 13 would be a leaf node. So both the left and right pointers would be -1. Okay, so keeping this in mind, now we are just directly putting the value into the array. Okay, so this is not to be confused with the object-oriented part. Okay, in the object-oriented part, we were kind of doing the same. We were first finding the right spot to put the node in, and then we were storing it in the array in the right spot and updating the pointers. Here, kind of we're doing the same. We're first storing the values at the next available space. Wherever we find the space, we're just going to put the node there, and then we're going to change the value of the left pointer and the right pointer. Okay, now this is from where the real thing will start. If the root pointer is equal to -1, that means the tree is empty. So the first node will be set as the root node. So whatever the free node value is, we set it to root pointer. So free node would by default be set to 0. Okay. Otherwise, we'll now have to loop through the tree. So what we're going to do now, we'll say placed is equal to false, which means that right now we have not found the right inserting point for the tree for the new node. And then we have the current node and we have the root pointer. Okay. So as always, we'll start from the root pointer. In our case, the root pointer would be starting from index 0. So this is where our root pointer is. And this is where our free node is. Okay. So we're going to start and this is the current node value. Current node is starting from index 0. Let's call it. So we don't really need the head root pointer. Let's call it current pointer. Like this. You can choose any names or conventions. Okay. If the node data, the node that we're going to add, this is the new node data or new node. In fact, let's call it new node. It would be simpler. I'll modify it above as well. Okay, if the new node that we're going to add, if the value of the new node is less than the value of the current node's data. So what does this mean? So column 1 is essentially the data, column 0 is left, and column 1 is right. So same logic as we saw before, except now this is in the 2D array. So we are checking if the value of the new node, if it is less than the current node. So current node is right now pointing to in row 0. So we're saying row 0,
What's
column
current?
1. Current node is just the pointer to our array, to this
Like,
2D array.
how did we get it?
We just started, we just set it to root pointer and we set the root pointer to 0 initially. Well,
Okay.
-1. We're assuming that there would be some values in it. Okay.
Okay.
Okay. So we checked. We are going to row 0, column 1. So again, row 0, column 1, we get the left column 1. This is the data value. So we check against this value. So the value that we're going to add could be, let's say, maybe 35 this time again. So we check
How
if
can
35.
a pointer be -1? Like, Abhi, you said the root
No,
pointer
no,
is -1.
we are by default setting it at to -1, and that would only happen when the tree is entirely empty. There are no values in the tree.
Yeah, but now we're in the else wala part. What's in
Yes,
root
and
pointer?
the else vola part would be triggered when we have some values in the tree, and that is why I've already added 2 values in it. That is how we're in the else part. Okay. Otherwise, it will, for the first part, you will actually have to put the free node onto the root pointer. So whatever the root pointer is, if it is right now -1, so the free node would be 0. So you're saying that start from this node 0 and put the values here. So we're assuming that this has already been done. Okay, there are at least 2 values present.
Yes, but how are we getting the node, the starting one that we're using in the else wala part in line 19 onwards?
Okay, so free node will already be pointing to 0. So when we have to add a new node, we already go ahead and put the value at the free node. Okay, so let's say I'll just take these values away like this. Okay, I'll take these values away. So we're saying that at free node put -1 and put the data and put -1 here. So as soon as we have any data and the tree is empty, we're just going to put -1s, and we're going to store some data here. And then we are checking if the root pointer is equal to -1. Again, just remember, we are not setting the pointers right now. Okay, we just added the value into the array, which is representing the binary tree, but it is not in the right format. It is not in the right structure. So here we're checking if root pointer was equal to -1, which is the case. Initially it would be equal to -1. So then we're saying that save the free node into the root pointer. So the value of the free node would be 0. So root pointer becomes 0, which means now officially this is going to be the start of the binary tree from node 15. Before that, it had no start. Before that, it was just an empty tree like this. Make sense?
Yeah.
Okay, perfect. So then we move on. Okay, then we again start from the current pointer and we set it to the current node. So we were doing this part. So we looked at the values of the column 1 and we checked if the value is the new node is less. So let's say if the new node that we're adding is 35. So since 35 is going to be greater than the value at the current node, we are going to get the value. So the value is yes, so we have to go right. So this if condition would not work. So we go into else, and we're going to check if the current node right pointer is equal to -1. Okay, let's check. So we have in row 2, and we set -1, -1, and then free node goes to 3. Okay, now 35 is in the array, but again, this is not part of the binary tree yet. So what we're going to check now is we're checking is the right pointer to the current node. So current node is right now pointing to, we started from this 20. So let's draw it here as well. So we have 20, then we have left is 13, like this. Okay, I'm going to add 35 now. So we're checking the value at 20 because 20 is the root right now. So we're checking if the pointer of the current node, which is 20, is the right pointer to it -1. Okay, we can clearly see there is no node on the right of 20, and we can also see that in the array that on the right it is -1. Yes, so that is the case. So what we're going to do is we're going to assign the value of free node onto the right pointer. Okay, now where was free node pointing to? I mistakenly made it here. So free node was pointing to this current row that we inserted the new value in. So what I'm going to do now is I'm going to update, store the value. So if I write it here, copy the value of free node into current node's right pointer. So current node was this 20. So we go to the right node of 20, the right pointer of 20, and we're going to update it to the free node value, and the value of free node was set to 2. This is where we added the value. And this now officially 35 becomes part of the tree. So now if I insert 35, these two things are literally the same now. So this 2D array now is representing this binary tree. And then that means that we have placed the node in the binary tree. So we set the place to true. And then when we go back, so the while loop will not work. Okay, now in what case will this while loop repeat? So let's look at that as well. So I'll undo this. All right. So we have the new node here. Let's say we have this this structure now. We have 20, 30, and 35. 20 left is 13, and 20 right is 35. Okay. Now the new node we're going to add would be maybe 100. Okay. So for 100 we have to go to 20. Then we see if there is a right value to the 20. Yes, there is. So now it's not equal to -1. So we have to repeat the same process again. So we're going to add 100 now. So let's see. The new node is 100. So we are saying, and also at the end, we incremented the free node by 1. So free node will be pointing to row 3. So we're going to add 100 now. So 100 index 0, the left pointer would be set to -1. Data would be set to 100, and right would be set to -1. So it will be -1, 100, -1. Okay. So this is going to be our new node. I'll just give it a color. This is the new node that we have right now. Okay. Root pointer is not equal to -1, place is equal to false right now, and root pointer is copied into current node. So root pointer is 0, so current pointer also becomes 0. Okay, not placed. All right. New node value is 100. So we check is the value at the value of 100 less than the value at the root. So at the root we have 20. So obviously we have to go right. So we skip all of this if, and we go to the statement. We check if the value of the current node's right pointer is equal to -1. Okay, let's see. So at the 20, at the this 0 node at index 0, the value of the right is 2. So it is not equal to -1, which means we cannot insert the value yet. We need to go to the second row now. So we'll go to the second row and we'll get 35 here, and 35's right would be -1. Now it means we can actually update the pointer. So that's what we're going to do. So since it is not equal to -1, this if condition will not work. So instead we go into else and we say get the right pointer now of the current node. Okay. So what was the current node? Current node was set to 0. So what is the at the right pointer of node 0? This is 2. So we're saying that get the value from the right pointer and assign it into current node. So current node now becomes 2. So now this would be current pointer would be Yes. So current pointer would now go to this row, which should contain 35, right? Because we have to go to the right of 35 now. Okay, so this happens. I'll undo this now. And the while loop is going to restart. Again, we did not set place to true, so place is still equal to false. Okay, next time we repeat. So we add 35 right now, and we have to add 100. So 100 is again greater than 35, so we have to go right. Okay, again, we're going to get the current node. So the current node is standing at 35. And what is at the right of 35? At the right of 35, we have -1. Now this means we can add the value here. So we are going to add the value. So free node, the value of free node is this. It's pointing to the row which contains 100, which is row number 3. So we're going to store 3 onto the current node's right pointer. So the current pointer is stored at the current node is, let's call it current node to avoid confusion. So current node is right now pointing to 35. So we're saying that update the right pointer to 3. So this current node's right pointer is -1 and will now update it to 3. And I'm going to underline this because it just changed. Right? So now 35 is going to point to node 3, which contains 100 now. And since we have placed a value at the right point, so this means that we've actually inserted the value. So what happened? We first added 20, then 35. So 100 goes after 20, and since there's a value after 20, so it goes after 35. And since there's no value after 35, we can store 100. So since the value has been placed, if we go back, value has been placed, so the loop ends, and we increment the value of the free node by 1. So free node will now point to index 4, and we do not need to highlight this anymore. And with this, we have successfully placed the value into the binary tree in the 2D array. Yes, any questions now? Yeah, do you guys get everything? Okay, so I'll assume you guys get everything. So just last thing for today would be the search. Okay, this is a recursion as well. So we'll do it next time. I think we're out of time as well. So we are left with recursive search.
I have one question.
Yes.
I'm still confused about the root pointer being -1 in the beginning, and then in the else statement, what would be the current node if the root pointer was initially -1?
In the tree wala part or 2D array?
In 2D array.
Okay, so if root pointer is set to -1, yes.
And then first we check if the root pointer is equals to -1, which in this case it is. So we'll assign the free node, which is 0. But if it was not, as in the else statement, what would the root pointer would still be -1. So how will the current node be -1? Because
No. How can the root pointer be -1? So when this if condition is not true, so we go into else. That means root pointer is not equal to -1. No.
okay, so if it's not equals to -1, what was the root pointer? Like, where does that value come from?
It would come from this part. So if this is not the case, तो आपने यहाँ पे okay, I think I get your question now. Root pointer was initially set to -1 here. Okay, so you're saying we
Like
never.
if there were
Yes,
nodes
okay.
in the array.
I got it. So you're saying we
Yeah.
never change the value of root pointer. Okay. So in binary, we are just assuming that we'll start the root pointer from index 0. Okay. Because हमने जो हमारी 2D array है वो हमने हमेशा 0 से यहाँ पे start किया. So this is not like linked list कि आप किसी भी node से start कर सकते हो. So binary tree की implementation में you cannot start from 35 or you cannot start from 13 or you cannot start from 100. You must always start from the root node. And by default, we're going to store the root node at index 0. So that is why we are
So
never.
it will always start from 0?
Yes, it will always start from 0. I just got your
Okay.
question now.
Okay. So if we don't make this if statement, it'll be the same thing because it's going to be 0 either way.
Yes, you're right.
Okay, ठीक है.
All right, so perfect. I'll see you guys tomorrow. And tomorrow we'll be doing this recursive search. And then we have in order, post order, and pre-order. These are just ways of accessing the binary tree. So it's very simple if you know recursion. So this is just 3 lines of code, and same thing applies on search. So take care then. Nafis. Bye bye.
Allah Hafiz.
Often